So what am I going to be talking about? I'd like to uh, share with you all some research I did last year that's related to sign language. And specifically, I kind of have like a long title here. One way I think about it is trying to find one place where typical natural language processing models go wrong when it comes to sign language, why that is, and then what we can do about it. So first of all, we should probably review what is sign language. So sign languages, plural, they're a bunch of fully developed languages where signers communicate with their body. So usually their hands, facial expressions, even their gesture, posture, instead of their voice. And it's a common misconception that sign languages are kind of like limited or very simple, but they're extremely complex. You can do pretty much anything you could do with spoken language, so like humor, poetry, and much more. It's estimated that over 70 million people communicate with sign language globally. And the most common sign language in the US in particular is American Sign Language, or ASL. I thought might as well, get moving a little bit. It's like 8 in the morning for a lot of you. So let's try signing your name. So if you want to say my name is, you would say like, this is I, and this is name. So you would say like kind of like I am named, and then you would finger spell your name. So for me, that would go Marcos. So altogether it'd be like, my name is Marcos. So I just want to give a second and try and find like the letters in your name. Keep moving a little bit. If anyone's confident, they can show show how they finger spell their name.
Okay, ready.
Let's see Jalen. J, yep, A-L-A-N. Yeah, you got it. That's it. Awesome. Thank you, Jalen. So yeah, this is just a little bit to get used to what it's like to have to use your hands to communicate. And so a very big field right now is working with sign language translation. It doesn't have to be using machine learning, but a lot of it is to try and not only understand what people are saying when they're signing, but also to generate like animated figures that are signing, so you can convey sign language to people. And so like one big company that's doing that right now is Signal. But there's a lot of hurdles that you run into when you try to translate sign language. So I'm curious, feel free to put in the chat what you might see as potential issues trying to translate sign language that you wouldn't have with most other spoken and written languages. Curious if anyone has any ideas. Yeah, absolutely. There are for a fact different grammar structures in sign language. So I'll teach the movements. That's right. So you can convey so much information in how you move. So for example, if you're illustrating the way something moved, like a car, you could do it fast or slow, and that would change what you're saying about how the car moved. You need to track hand movements. Yeah, so this whole computer vision aspect of it. And yeah, it's true. You can't translate sign language in Google Translate because like you can't really type it in, and you can't really play it back. Yeah, so it's a little more complicated. And so feel free to keep putting things in the chat. I'm going to move along just so we can kind of keep things on time. And so I'd like to point out one particular issue that I think has been kind of understudied. So here's how you can break up like a written sentence. So I have this sentence: a woman is riding a horse. The horse sees a fence and jumps over it. And to split it up into its like most essential parts, pretty much you can do it with spaces. Like spaces are super helpful. And actually, I'm basically done here. I've broken up this sentence into its component parts. So written language is super, super easy. But you have an issue with sign language that can happen where, first of all, you have a video, right? And you have to split up that video into different parts that correspond to different signs. So here's like woman, ride, horse, so on. But here at the end, we have something interesting happening, which is that this woman is using one hand to represent the fence, one hand to represent the horse, and she's showing the horse jumping over the fence. And that's kind of a problem because that's kind of like two signs happening at once. It's not a unique sign. This isn't like the symbol. This isn't the sign for horse jumping over the fence, right? It's a horse and a fence, and you're showing what happens to it. And so this is not easy. This is a problem. And actually, this will break, no like traditional NLP model will know what to do with this. And so that's what me and a few other undergrads try to figure out. We spend like a semester working on this problem. Just a little bit more background. So these hand shapes, they're called classifiers. And that's not to be confused with classification, like in the machine learning sense. These are hand shapes that are typically used to represent certain shaped objects. So as an example, here's the 4 classifier. It looks like a 4, right? And you can use it to represent a whole bunch of things. So anything that has like stripes, like bars or a fence, upright boundaries, or a whole bunch of other things. So people standing in a line maybe, or objects that flow or leak. So they're basically some really common hand shapes that can be used to represent certain things. So what we wanted to do is we wanted to take a very simple problem, so just one piece of the puzzle, and see if we could take something like this, which is a video of a person moving their hands, to given this video, to turn it into something like this: classifier A towards classifier A. In this case, because both hand shapes are the classifier A hand shapes. So that was our question, because this would be kind of like a ground zero, like a starting point for maybe recognizing these more complex motions. So here's our model. I gave it eyes in a hat just to anthropomorphize it a little bit. So what it'll do is it'll take in a video, so a series of images, and then it's going to predict a bunch of tokens. So like, let's say it guesses classifier A, classifier 3, near, and then a special end token. And then that would get compared with the correct answer. And so what it needs to learn a couple of things. For one thing, it needs to learn what the hand shapes and the motions are. That's difficult in and of itself. But it also needs to learn this kind of like basic word structure. So it also needs to learn how to like order these three things and put together a very simple sentence. So we're hoping that could illustrate how this might work in a more complex problem. And so what I've done here is I've kind of blown up the inside of the model so we can see what's on the inside. And so just really quickly, basically what happens is I have a bunch of different classifiers for the 3 different things that you need, right? You have to figure out what is their left hand shape, what is the right hand shape, and what is the motion that's happening between them. And after that, it gets passed into a special model called an encoder decoder, which I'm not sure would have come up in previous workshops. But basically, it can learn to predict a sequence of things. And so what's going to try to predict is a sequence of tokens that match the correct answer. So here's what we hope to see. So we're imagining, let's say this model has seen a couple of these sentences before. So it saw classifier A over classifier 3. It saw classifier Y below classifier 5, and it saw classifier B near classifier 1. So it's seen those things. So it's seen like classifier A, that hand shape, the classifier Y hand shape, the near motion. So it's seen those 3 things, but it's never seen this particular sentence of classifier A near classifier Y. And so what we'd hope is, even though the model hasn't seen this particular sentence, it has seen those individual hand shapes and motions. And so it can kind of synthesize those together and correctly predict the sentence. And on the whole, that's actually what we saw, which we were really excited about. So this model, which now has a party hat, could correctly translate, granted in this very simple sentence structure, about 83% of the hand shape or the combinations that it hasn't seen before. So it's learned the hand shapes and it's learned the motions and it's learned the sentence structure, and it can correctly translate new combinations of those. So why does this matter? For one thing, this is truer, at least we believe it's truer to how people actually sign. When they're thinking about hand shapes and they're thinking about motions, it's not always the case that you can split it up into one sign at a time. And also this can help decrease the amount of training needed, because now the model can learn to combine hand shapes and motions that it's seen before, instead of treating everything as a certain sign. Because otherwise you need to learn like that this means like horse over fence. Well, it's not really the case. You're just like doing a few things at a single time. So that's actually all I have. Thank you for listening. I hope you enjoyed. And if you have any questions, feel free to message me.